Hey, welcome back. This is section 6.3. We're going to talk about some geometric series. In this video, we're going to derive the formula for the sum of a finite geometric series where r is not equal to 1. We're also going to use that formula to solve some real-world problems. So a geometric series is the sum, which we're going to denote as S sub n, of the terms of a geometric sequence. So if we consider this geometric sequence right here, the geometric series for that sequence would be that sequence written out as a sum. So we would do negative 15 plus 30, which is 15, and then minus 60, which is negative 45, and then add 120, and you get 75, and then subtract 240, and you get negative 165, and then add 480, and at the end you get 312, or 315. Now that's a lot of work to do, and that was just 6 terms. So how do we deal with this when we have more than 6 terms? Well, we came up with something we call summation notation. Summation notation uses the Greek capital letter sigma to indicate a sum. This is the Greek capital letter, and the formula itself, so we're going to put the explicit formula for the sequence right here. And then we're going to put the lower limit, which is where are we starting? A sub 1, A sub 2, when n is 4. And then what is the upper limit? That is, at what term are we stopping? So, for example, if we were to use some summation notation to evaluate this, we're going to start at n equals 1. We're going to stop when n equals 6. And we're going to put each value for n in the formula right here. So this would be equal to 2 to the first n, which is 1, plus 2 to the next n, which comes after 1 is 2, plus 2 to the next n, which is 3, plus 2 to the next n, which is 4, plus the next, which is 2 to the 5th, plus 2 to the 6th. And we're going to stop at 6 because this tells us when you get to n equals 6, you stop. Okay, so now this is 2 plus 4 plus 8 plus 16 plus 32 plus 64. And so when we put that in our calculator, we get 126. Okay, go ahead and you try this one. Remember, the explicit formula is on the right, lower limit is on the bottom, the upper limit is on top. Unpause the video when you're ready. Okay, welcome back. So you put in each value for n starting at 0 and going up to 4, and when you simplify each expression and add them together, you get 121. Okay, let's try another example. If we want to use summation notation to find this value, so now we have a slightly more complicated explicit formula. So in this case, same thing, we're going to start when n equals 1, and we're going to stop when we get to n equals 6. And we're going to put n into each of this explicit formula and adding the whole time. So we have negative 15 times negative 2 to the n minus 1, so 1 minus 1, plus negative 15 times negative 2 to the 2 minus 1, plus negative 15 times negative 2 to the 3 minus 1, plus negative 15 times negative 2 to the 4 minus 1, plus negative 15 times negative 2 to the 5 minus 1, plus negative 15 times negative 2 to the 6 minus 1. Okay, so this first term right here, we can simplify 1 minus 1, and we get 0. So anything to the 0 power is 1, but we'll rewrite it 15 times negative 2 to the 0. Now do the next term right here, and we get negative 15 times negative 2 plus, do the next one right here, negative 15 times negative 2 squared. Do the next problem, plus negative 15 times negative 2, 4 minus 1 is to the third, plus negative 15 times negative 2 to the fourth power, 5 minus 1, plus negative 15, and negative 2 to the 6 minus 1 is negative 2 to the fifth. Okay, so let's simplify one more time. So negative 2 to the 0 power is going to be 1, so that's negative 15, plus negative 2 to the first power is negative 2, and so negative 15 times negative 2 is positive 30. And then we have negative 2 squared is going to be positive 4, and positive 4 times 15, or negative 15 is going to be negative 60, so minus 60. And then next we do negative 2 to the third, which is going to be negative 8 times negative 15, which is going to be positive 120. And then we're going to get negative 15 times negative 2 to the fourth, and negative 2 to the fourth is 16, and so 16 times 15 is going to be 240, so negative minus 240. And then negative 2 to the fifth is 32, and 32, negative 32. Negative 2 times negative 15 is positive 480. Okay, and so then we can go ahead and simplify that, and we get a sum of 312. So S sub n here equals 312. Okay, go ahead and try this one. Remember, we're using summation notation, so you want to use the explicit formula, the upper limit, and the lower limit to then sum to your answer, which is down at the bottom. Okay, so why did we go over summation notation? Well, summation notation can be a shortcut if you have a really long sequence. And it also leads us to the sum of a finite series, which is this formula right here. And so the first term, a sub 1, is here, and then we have the common ratio and the number of terms. And in class, we're going to actually derive this formula, but I wanted to get you familiar with it first. So to solve a problem similar to the one we had before, we can go ahead and just put that in the formula. So we know that a sub 1 is the first term, so that's negative 15. And we can use the first two terms to find the common ratio, because we can divide 30 by negative 15, and we get negative 2. So we know r is negative 2. And then we know n because we can count the number of terms, 1, 2, 3, 4, 5, 6. So we know n equals 6. And so once we have these values, we can go ahead and plug it in to our formula. So we know S sub n equals a sub 1 is negative 15 times 1 minus r to the n, and r is negative 2 to the 6, all over 1 minus, and r is negative 2. Okay, so let's simplify that a little bit. Okay, so now that we have this, we know that 2 to the 6th is 64. So now we have negative 15 times 1 minus 64 over 1 minus negative 2 would be 1 plus 2, which of course is 3. Okay, so now we have negative 15 times negative 63 over 3, and negative 15 times negative 63 is 945 divided by 3 is the 315 that we got earlier when we added all of these together. Okay, so go ahead and you try. Find the sum of this finite series. Remember, this is the formula. Pause your video when you're ready. Okay, welcome back. If you got a little stuck, remember, think, what do you need? So go ahead and see if you can fill those out. Okay, welcome back. You found that these are what you were looking for. So pause the video at any time so that you can try some on your own. So we put that into the formula, and there was your answer. Let's say, for example, that Miss Folger buys a bunny and it eats 4 carrots on the first day. And then the second day, it eats 12 carrots. And the third day, it eats 36 carrots. And by the fourth day, this little monster is eating 108 carrots. Some days later, I realized that my bunny ate 972 carrots in one day. Now this is a geometric sequence. We can see that 4 is being multiplied to 3 to get 12, which is then being multiplied by 3 to get 36. So we have what we would call a geometric series, and we can use the formula. So we need to figure out what we have. We have a sub 1 is 4, and we know that r is 3. But we're missing n. So how can we find n? Well, we know from a sub 1 and r, we can write an explicit formula. And so, in fact, we can use the explicit formula to find n. If we know that a sub n, right, because if this is a sub 1 and this is a sub 2, then some days later this would be a sub n. So we know that 972 must equal the initial term, which is 4, times the common ratio, which is 3, to the n minus 1. So we can use inverse operations to divide each side by 4. And we end up with 243 equals 3 to the n minus 1. We don't really have a way to solve this until we look at our powers and bases table. And we notice that 243 is 3 to the 5th. Well, if 3 to the 5th equals 3 to the n minus 1, if the bases are the same, and these are equal, then the exponents need to be equal. So this means that 5 here must equal n minus 1. So 5 must equal n minus 1. If I add 1 to both sides, that means n equals 6. And so I can go ahead and fill that in, that n equals 6. Now I have everything I need to use my formula. So S sub n equals a sub 1, which is 4, times 1 minus r, which is 3, to the 6th, all over 1 minus r, which is 3. And so we go ahead and simplify. We're going to start with what's in the parentheses, and what's in the parentheses is an exponent. So S sub n equals 4 times 1 minus 3 to the 6th, which is 729, over 1 minus 3, which is negative 2. So S sub n equals 4 times 1 minus 729 is negative 728 over 2. So 4 times negative 728 divided by negative 2 is 1,456. So Miss Folger's rabbit ate 1,456 carrots since Miss Folger bought it. Okay, I want you to go ahead and try to find the sum of this geometric sequence. Pause the video and get as far as you can. Okay, welcome back. So we're looking to use this formula. We need this information. Make sure you're pausing the video as you think you can figure these out. We're going to use the explicit formula to find n. So there's our answer. Okay, we can also use this formula to solve real-world problems like the one below. So take a moment to read. Okay, welcome back. So we notice that it gives us some information, and it wants us to find the starting population, so that's a sub 1. And we know in the formula, then, if we need to find a sub 1, we're going to need the total sum, which it says there's 1,295 bacteria. We're going to need to know the number of hours, which was 4 hours, and we're going to need to know the factor by which we're multiplying each term. So the common ratio is 4, and the number of hours, the common ratio is 6, and the number of hours is 4. So let's go ahead and plug that into the formula. So we know S sub n is 1,295, and that's going to be equal to our starting value, which is A, we don't know that yet, times 1 minus R, which is 6, to the n, which is 4, all over 1 minus R, which is 6. And so let's go ahead and simplify. So 1,295 equals A times 1 minus 6 to the 4th, which is 1,296, over 1 minus 6, which is negative 5. So now I can multiply both sides by negative 5. And that gives me negative 6,475 on the left. And A times 1 minus 1,296 is negative 1,295. And so I can divide both sides by negative 1,295. And I get that A equals 5. And so that means the initial population of my bacteria colony was 5 bacteria. Thank you so much for listening. If you want to watch some more examples, go ahead and watch some more examples video. Otherwise, complete the 6th 3 geometric series reflection and enjoy your winter break after next week's exams.